Hello students, welcome to the Quick Solutions All India AIATS Test Series JEE Advanced 2021 Test 1A Paper 1. Let's go to question number 1. Question 1 says, if a particle is projected from P 2, 3, 5 and it reaches point Q 3, 4, 5 under the action of a constant force which produces the acceleration A equal to 4 root 2 cos 45 degree I cap minus sin 45 degree J cap, then which of the following statements are correct? Option A says displacement vector R is equal to I cap plus J cap. B says minimum speed of the particle is at P 2, 3, 5. Initial speed of the particle at P and final speed at Q will be same. Option D says angle between displacement vector and acceleration vector is 30 degree. Well, it's very simple to find the displacement vector. This is the final position vector minus the initial position vector, and this is equal to 3 minus 2 or simply I cap plus 4 minus 3 J cap or J cap and plus 5 minus 5 K cap, which is 0 K cap. So this is the displacement vector. Let's now evaluate option B, which says minimum speed of the particle is at P, which is 2, 3, 5. To evaluate this statement, we draw the XY axis. Okay. Of course, the motion is happening in a plane parallel to the XY axis, where Z is constant at 5. So let's see in the XY plane, the initial position vector of the particle is 2, 3 in XY plane. So let's say this is 2, somewhere here. Particle is being projected from somewhere here. This is point P. And from here, the displacement R vector is I cap plus J cap, which makes 45 degree angle with both X axis and the Y axis. So this is our displacement vector, vector R. If I draw the acceleration vector we can see on simplification is 4 I cap minus 4 J cap. So the acceleration vector makes 45 degree angle with X axis and 45 degree angle with the negative Y axis. So which means the acceleration vector is something like this. Now if this is the X axis, this line is parallel to X axis, this angle is also 45 degree and this angle is also 45 degree. That means the acceleration vector is perpendicular to the displacement vector. Now it's very clear that the motion will be projectile motion, the path will be parabolic, and it will, let's say it is something like this. It starts from point P and let's say it ends at point Q. We can now relate to a normal projectile motion, right? It's very clear that as the particle is going away from this R vector, the line of the R vector, which let's call it as X dash axis, and perpendicular to this in the XY plane is, let's say, Y dash axis. Then as the particle is going away from the X dash axis, so speed will be decreasing. At the highest point, the Y dash component is 0. So it clearly means that as the particle is going like this, its speed is decreasing, and at the highest point it is minimum. Highest point means at the maximum distance from the X dash axis, and then the speed starts increasing, which means option B is incorrect. Now option A was correct, so let's tick it. Option B is incorrect. Option C says initial speed of the particle at P and final speed at Q will be same. Now this will be correct because this line, the displacement is perpendicular to acceleration, and if it has gone from P to Q, that means displacement along y direction, that means displacement along the acceleration vector has become 0. So at this point the speeds will be same. Of course the velocities will be different, but the speeds will be same. So option C is correct. Option D says angle between displacement vector and acceleration vector is 30 degree is obviously wrong. We have seen that this angle is 90 degree. So for question number 1, options A and C are correct. Let's go to the next question now. Question 2 says in the system shown in the figure, M1 is greater than M2. The system is held at rest by thread BC. Pulley is light and smooth and its axle and spring is of stiffness K. The pulley is light and smooth at its axle and spring is of stiffness K. Then option A says tension in string BC at equilibrium is T equal to this much. Option B says tension in string BC at equilibrium is T equal to this much. Option C says if the string BC is burnt at T equal to 0, then just after burning the acceleration of mass M1 is A1 equal to this much. And option D says if the string BC is burnt at T equal to 0, then just after burning the acceleration of mass M2 is A2 equal to this much. So let's evaluate each statement. Let's look at tension in string BC in equilibrium. Well, if we look at block of mass M1, this will cause a tension in the spring of M1G, right? And that tension is everywhere. So if I draw FBD of M2, there is force tension, let's call it T1, which is equal to M1G, which is acting in the upward direction. Its own weight is M2G, and let's say there is some tension T2 in string BC. So it's very clear that T2 is equal to M1 minus M2G for equilibrium, which means option A is incorrect and option B is correct. Now let's look at option C and D. What happens when the string BC is burnt? So when the string BC is burnt, just after burning of string BC, acceleration of M1 will be 0, because there is M1G downward and the tension in the spring, which is also M1G, which is acting upward, so it's in equilibrium. Of course, after that block will come into some acceleration, but just after burning of string BC, acceleration of M1 is 0. So that means option C is incorrect. What about acceleration of M2? So just after burning, this tension will go. So there is this force M2G and the upward force is M1G. M1G is greater than M2G. So let's say the acceleration is A. It's very clear that acceleration A will be equal to M1 minus M2G divided by M2, which means option D is correct. Let's now go to question number 3. Question 3 says a small ball of mass M is rotating in a circle of height h from ground level with uniform speed v inside a smooth cone as shown in figure. Let n be the normal reaction on the ball by the cone, then choose the correct options. Let's draw the free body diagram. The options are about v square, and then there are options, 3 options about n. So let's draw the free body diagram. So there is this force mg, weight of the particle. There is this normal reaction, and under the action of these two forces, the particle is performing a circular motion, right? Because it says the ball is rotating in a circle of height h from ground level. So let's say the radius is r, and we can see that this angle is theta, this angle is also theta. So for vertical equilibrium, n cos theta equals mg, and horizontally n sine theta provides the centripetal force, which is mv square by r. We can also see in this triangle that tan theta equals h by r. So we can replace r by h by tan theta. So we get n sine theta equals mv square by h by tan theta. Let's look at the options again. Now if we take these two equations, equation 1 and equation 2, divide them, we get tan theta equals, that means we're dividing equation 2 by equation 1, we get tan theta equal to v square tan theta by gh, or v square is equal to gh, which means option A is correct. Let's look at other options now. N is equal to mg cos theta will be wrong because n is mg by cos theta. So option C is correct. And option D says n cos theta is equal to mv square by h. So we can use this equation now, or rather this equation, and if we put tan theta is equal to sine theta by cos theta, we will get n cos theta equals mv square by h. So that means option D is also correct. So for question 3, options A, C and D are correct. Let's now go to the next question. Question 4 says, a projectile projected from the ground at t equal to 0 with initial speed u at angle theta with horizontal. Then option A says, if at time instant t velocity of projectile is perpendicular to its initial direction of projection, then angle of projection theta is greater than pi by 4. Option B says, if at a time instant t velocity of projectile is perpendicular to its initial direction of projection, then angle of projection theta is less than pi by 4. If at a time instant t velocity of projectile is perpendicular to its initial direction of projection, then t is equal to u by g sine theta. And option D says, the angle between velocity vectors at instant 1 second before reaching maximum height and 1 second after reaching maximum height is delta theta equal to 2 tan inverse g by u cos theta. So let's evaluate each and every option. Now, particle is projected at angle theta with speed u, and at some instant t its velocity is perpendicular to initial velocity. So if I draw it here, let's say this is the path of the projectile, something like this. Initial velocity is like this, and at some instant the velocity becomes perpendicular. That means somewhere it is here like this, and a tangent to this path, this angle is 90 degree. So here is velocity, let's say v, and initial speed was u. Now this velocity is perpendicular to initial velocity. So if we equate the horizontal components, what do we get? So here this angle was theta, and let's say here the angle is alpha. So we can see that horizontal component of velocity will be equal, which means v cos alpha equals u cos theta. But since the two velocities are mutually perpendicular, so v cos alpha is same as v sin theta, right? So that means v sin theta equals u cos theta, and that means tan theta equals u upon v. It's very clear that v will be less than u. So which means tan theta is greater than 1, and that means theta is greater than pi by 4. Which means option A is correct and option B is incorrect. Let's evaluate option C now. It says the velocity will be perpendicular to initial velocity at t equal to u by g sine theta. We already know the value of v. V is u cot theta, right? So Vy will be minus u cot theta into sine alpha, right? And which is minus u cos theta by sine theta into sine alpha is again cos theta, and this is equal to u sine theta minus gt. If we solve for t, we get t is equal to u into sine theta plus cos square theta by sine theta divided by g. Solving this will come out to u by g sine theta. No, we can use the identity sine square theta plus cos square theta is 1. So this is the time t equal to u by g sine theta at which velocity will be perpendicular to initial velocity. So option C is correct. We can use another method for evaluating this option further, and so let me show you that. The other method will be this, that we write initial velocity as u into cos theta plus cos theta I cap plus sine theta j cap, and velocity v at that time is u cos theta I cap plus sine theta j cap minus gt j cap. Now since v is perpendicular to u, so u dot v is 0, which gives us, if I take the dot product of these two, what do we get? We get u square cos square theta plus u square sine square theta minus u sine theta gt is equal to 0. This gives us again t is equal to u by g sine theta. So option C is also correct. Let's look at option D now. It says the angle between velocity vector at instant 1 second before reaching maximum height and 1 second after reaching maximum height is this. So just 1 second before reaching maximum height, what is the velocity? Let's call it v1. It is u cos theta I cap. The horizontal component does not change, and the vertical component will be numerically, because Vy is going to be 0 after 1 second, right? So if I put it like this, that 0 is equal to V1y minus g. So this gives us V1y equal to g. Okay. So at this instant, if I draw this component is g numerically and this is u cos theta. So with the horizontal, the angle is tan inverse G by U cos theta. Okay, so just 1 second before reaching the maximum height, the velocity is above horizontal and it's above horizontal by tan inverse G by U cos theta. After 1 second, it will be below horizontal by the same amount. So if I look at the statement, it says the angle between velocity vectors at instant 1 second before reaching maximum height and 1 second after reaching maximum height is this much. So actually the angle between these two velocity vectors will be 2 times of tan inverse G by U cos theta, which means the option D is correct. Let's now go to question number 5. 5 says, if V is the velocity of the particle at any instant and F is the resultant force acting on it, then mark the correct statements from the following. If V is opposite to F and mod F remains constant, then particle will retrace its path. Well, if the resultant force is opposite to velocity and its magnitude remains constant, then it's very clear that the particle will retrace its path. Its velocity will at some time become 0, and after that it will start retracing its path. So option A is correct. Let's look at option B. It says if V is perpendicular to F and magnitude of F remains constant, then particle will move in circular path. This is a correct statement. Like this is what happens in case of uniform circular motion. In uniform circular motion, the net force is perpendicular to velocity at all the time and its magnitude remains constant. So this will be a case where there is uniform circular motion. So option B is also correct. Let's look at option C now. It says if initial velocity V and F are not along same direction and F remains constant, then particle will move in parabolic path. Well, if they are not along same line and F remains constant, then it will be a projectile motion. So option C also is correct. Option D says if V and F are not perpendicular at any time and F remains constant, then particle may move in parabolic path. Well, if V and F are not perpendicular and force vector remains constant, then in general particle will move along a parabolic path. So option D is also correct. That means for question 5, all 4 options are correct. Let's go to the next question now. Question 6 says, for a particle moving along x direction, the position x depends on time t, as x is equal to alpha t cube plus beta t square plus gamma t plus delta. Alpha, beta, gamma, delta are all positive constants. If at a unique time instant t greater than 0, the magnitude of acceleration happens to be equal to particle's speed, then which of the following conditions must satisfy? Okay. So magnitude of acceleration is numerically equal to particle's speed, then which condition must be satisfied? Velocity v is dx by dt, which is equal to 3 alpha t square plus 2 beta t plus gamma, and acceleration a is equal to dv by dt, which is 6 alpha t plus 2 beta. And since v is equal to a according to the question at some unique time t greater than 0, so we have 3 alpha t square plus 2 beta t plus gamma equal to 6 alpha t plus 2 beta, which gives us 3 alpha t square plus 2 into beta minus 3 alpha t plus gamma minus 2 beta equal to 0. And since t has a unique solution, So discriminant is 0, which means 4 into beta minus 3 alpha whole square is equal to 4 times 3 alpha into gamma minus 2 beta. Let's simplify. We get beta square minus 6 beta alpha plus 9 alpha square is equal to 3 alpha gamma minus 6 alpha beta. Okay, so it simplifies to 9 alpha square plus beta square, these terms cancel, minus 3 alpha gamma is 0. So this is matching with option A. Option A is clearly correct. Let's look at other options also. Now since A is correct, D is incorrect because it says this is greater than 0. So that will not be the case. And the value of T turns out to be, since discriminant is 0, then solving this quadratic equation again, we get T is equal to 2 into 3 alpha minus beta by 6 alpha. Now since this is greater than 0, we get 3 alpha is greater than beta. So which means option B is also correct and option C is incorrect. So that means for question 6, options A and B are correct. Let's now move on to the next question.